All right, so for graphing the function into inverse, we'll first start by making a table for f. So we'll start with x and f of x, and we'll plug in our standard numbers, -2, -1, 0, 1, and 2. And we're going to plug those into the equation up here, so this guy right here. So f of -2 will be -2 plus 3. So that'll be 2 plus 3, which is 5. And then for f of -1, plug -1 into our equation, -1 plus 3, and we'll get 1 plus 3, which is 4. For f of 0, we'll get -0 plus 3, which is equal to 3. For f of 1, we'll get -1 plus 3, which is 2. And for f of 2, we will get -2 plus 3, which is 1. So then we'll put these points on our graph here. So -2, 5, -1, 4, 0, 3, 1, 2, 2, 1. So these make this line here, and we will call this f. So now let's find the inverse. And all we need to do is remember the one thing we do for inverses, and that's flip the x and y. So flip the x and y. And so this will be at 5, -2, 4, -1, 3, 0, 2, 1, and 1, 2. So an interesting thing happens here, that our inverse, f inverse, and our function f are the same. So if you try to solve that for the equation, you will get the same equation if you find the equation. So interesting. All right, so here for this one, we'll make a table for f. But here's something interesting happens as well. If we plug in our usual -2 into this equation, we're going to get -2 minus 3, which will be the square root of -5. And this is a problem because we cannot have negatives under radicals. So we need to make sure that this is positive. So we know from our work earlier that the domain for this guy is x greater than or equal to 3, because if you take x minus 3 and make it greater than or equal to 0, add 3 to both sides, you get x is greater than or equal to 3. So the domain here is x greater than or equal to 3. So that means you should not be plugging in any numbers smaller than 3. So we'll start with 3 then, and we'll go up from there. So let's do 3, 4, 5, and then we'll try 7. So let's plug in 3. We'll get the square root of 3 minus 3, which will be the square root of 0, which is 0. Let's try 4. That'll be the square root of 4 minus 3, which is the square root of 1, which is 1. F of 5 will be the square root of 5 minus 3, which will be the square root of 2. That's not a nice number, but if we type it into our calculator, it's about 1.4. And then f of 7, square root of 7 minus 3 is the square root of 4, which is 2. So that's why I picked 7, because I knew it would be a nice number. So we have about 1.4 and 2. So we'll go ahead and graph that for f. So 3, 0, 4, 1, 5, 1.4, and 7, 2. So this graph is going to look like this. This is f. And so then for the inverse, we'll switch the x and y's. 0, 3, 1, 4, 1.45, and 2, 7. And then we'll graph these, 0, 3, 1, 4, 1.45, and 2, 7. So this one's going to look like this. And just a reminder that we're reflecting over this diagonal dotted line. So those are mirror images across that. If you were to fold the paper across that dotted line, those are mirror images. So those are our graphs. So then here, we will make a table for f of x. Here our domain is all real numbers, so you don't need to worry about what you're plugging in here. So it'll be -2, -1, 0, 1, and 2. So plug those into our equation. Don't forget to put parentheses around it if you use a calculator. This should be 5. This should be 2. This should be 1. This should be 2. And this should be 5. So we'll put those on our graph. So -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. And then if we find the inverse by flipping the x and y, (5, -2, 2, -1, 1, 0, 2, 1, 5, 2). Plot those. We have 5, -2, 2, -1, 1, 0, 2, 1, and 5, 2. And again, remember this is a reflection over this line here. So the blue one was f, and the red one was f inverse. And so they're perfectly symmetric along that line there. You can answer the domain and range about each of these. The important part is to realize that the domain and range are going to be the same they're going to flip for the f and f inverse. So if we have f here, the domain is, from the graph, you can tell it's all real numbers. And the range is also all real numbers because it's the y values are all real numbers. And then for f inverse, that means that the domain will be all real numbers and the range will be all real numbers because they'll be the same, they just flip. And then for this guy here, it's a little more interesting. For f, the domain starts at 3 and goes to infinity. And the range starts at 0 and goes to infinity, which we already talked about the domain up here. And so then f inverse, you can look at the graph if you would like, but we also just know that they switch. So the domain will be 0 to infinity, and the range will be 3 to infinity. And then for this guy here, for f, the domain will be all real numbers, because for the blue function it goes left and right forever, or negative infinity to infinity, and the range will be from 0 or from 1 up, so 1 to infinity. And you can look at the graph of f inverse if you want to try to find the domain and range, but they'll just flip.